Hello, today we're going to be factoring polynomials and solving polynomials. So previously we've been able to factor things like x squared minus 4 to be x minus 2 and x plus 2. And looking at that, we know that's the difference of two squares, and we know that this factoring works because when you distribute it, you get x squared plus 2x minus 2x minus 4. And that ends up being the same thing you started with. So today we want to learn a new method of factoring. We're going to be factoring something that's x cubed minus 8. Now people, when they look at this, say, okay, maybe it's just x minus 2 3 times. Well, unfortunately, that does not end up working out, because if you were to take and distribute this, you would not end up with middle terms that cancel out. You would end up with a polynomial that's not the same thing as x cubed minus 8. So we need a different way. So here's where sum and difference of cubes is going to go ahead and enter into the picture. So we can use this formula when we have one perfect cube and another perfect cube separated either with addition or subtraction. So it's important to note what our perfect cubes are, because we have to be able to identify if something is a perfect cube. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, and 7 cubed is 343. These are the most common perfect cubes that we need to be able to look at and know right off the top of our head. Once we figure out that something is a perfect cube, but with the number and the exponent, for instance, x cubed is a perfect cube, x to the 6th is a perfect cube, and x to the 9th, and so forth and so on, those are all perfect cubes, then we can figure out how to use this formula. So our formula is going to be, if you have two perfect cubes separated with addition, if you take whatever is being cubed and you write that as your first term and second term and plug it in for a and b, you can use this formula where it's a plus b, parentheses, times the quantity a squared minus a times b plus b squared. For instance, 8x cubed represents the quantity 2x itself being cubed. 27 is 3 being cubed. So we're going to use our formula with a as 2x. And when you're plugging in 2x, especially when you're squaring it, you want to make sure you're using parentheses. And then we're going to use b as 3, anywhere we see a b. When we simplify that, we would get our factored form. Likewise, this next one is the exact same thing. The only difference is that it's separated by a minus sign, so the positive and the negative cancel, or not cancel, but flip. So a cubed minus b cubed is a minus b times a squared plus ab plus b squared. So for this one, 5x is being cubed, as is 2. So we're going to plug 5x in for a, and then we're going to plug 2 in for b, and we're going to then simplify it to get our answer here. So this allows us to factor things that aren't normally factorable prior to today. So for instance, 8x cubed plus 1. This is going to be 2x quantity cubed plus 1 cubed. So a is 2x and b is 1. So we're going to do a plus b times a squared, here I'm using parentheses, minus a times b plus b squared. So we get 2x plus 1 times 4x squared minus 2x plus 1. First thing I'm going to do is just show you that this indeed actually works. So if you distribute here, you're going to get 8x cubed minus 4x plus 2x. Oops, sorry, minus 4x squared. Then plus 4x squared minus 2x plus 1. So the 4x squareds cancel out and the 2x's cancel out. We do end up with what we started with. So this formula works. The next thing I'm going to do here is I'm going to talk about what next. Normally, you'd ask yourself, can you keep factoring? This first term doesn't have anything else, so that is by itself, like we can't keep going. This second one here, when you use the sum and difference of cubes formula, think about what multiplies to get 4x squared minus 2x plus 1. And it's never going to factor further. Okay, you can't keep factoring. Okay, like if you're using your split middle term, 4 times 1 is 4. What multiplies to get 4 but adds to get negative 2? Nothing works. So the sum and difference of cubes is kind of like your last resort here, because after you use it, you can't keep going. So we're going to try another example here. So looking at this one, all of our factoring rules still apply. So we are going to look for a GCF first. So looking at these two, 27 and 125 have nothing in common. The x's have nothing in common with the y's. So now we're going to figure out what is being cubed, give us each term. So we get 3x cubed and 5y cubed. So our a value is 3x, our b value is 5y, and we're going to plug those into our formula. So it's going to be a minus b. The only reason that it's a minus is because of the sign in the middle, times a squared plus a times b plus b squared. So then we simplify 3x minus 5y times 9x squared plus 15xy plus 25y squared. So that would be our final factored form, because again, after you use the sum and difference of cubes, it's not going to factor further. So what I'd like you to do is actually pause the video and try number 3 on your own. Again, take out a GCF first and then keep going and then come back to the video. Okay, let's take a look here for number 3. Our GCF is negative 2w, and then we have 3w being cubed and 5z being cubed. So when we plug those into our formula with the minus sign, we would end up with our final answer as shown. Now, with number 4 and number 5, now these look very similar, but we're going to actually get very different results based off of how we're going to factor these. So we're going to use sum and difference of cubes as a last-ditch resort. So we're going to see, does anything else work first? And then we're going to go to sum and difference of cubes. What that means for number 4 is, if we're looking at this one, when we ask, does anything else work first? The answer is yes. These are both perfect squares. So we are going to write this using our difference of squares formula. So if I square root the first term, I get x cubed. If I square root the second, I get y cubed. I have one with a plus and one with a minus. So we're going to use difference of squares first. That trumps sum and difference of cubes. Because now, at this point, each of these factors further. Each of these, we're going to use x as our a and y as our b, and we're going to plug it in to our formula. Now, one of them is going to be the sum, and one of them is going to be the difference. So overall, this would be our final answer, as nothing else would factor further. Now here's why difference of squares trumps difference of cubes. Imagine you had done x squared, oops, that's a 2, being cubed, and y squared being cubed. Okay, this again is not what we're going to be doing, but imagine you had done that. You would get x squared minus y squared times x to the 4th plus x squared y squared plus y to the 4th. Now you might be saying, okay, well that looks like it's factored, right? This one would factor further to get us the x plus y and an x minus y, but this would not factor further very nicely. We don't know how to factor that. So that's why we do difference of cubes first, so that we don't get stuck somewhere. It might affect you actually when you're trying to solve. You might be not able to solve something that you're supposed to be able to. So let's take a look at number 5 then. Looking at this, does anything else work? And for this one, no, nothing else works, because this is not the difference of two squares, because it's a plus sign. So this is where we're going to do x squared cubed and y squared cubed. So we're going to use your sum and difference of cubes formula. So take a moment, try it, and then come back. Okay, so here we go. X squared plus y squared, x to the fourth minus x squared y squared plus y to the fourth. So that's a new method of factoring. Now what we're going to do is we're going to try to apply that in some different contexts. So for these ones, we're not going to use a new method of factoring, but we are going to have to be creative with how we try to factor it. Now it seemed very vague, right? So looking at this, normally you would try grouping. Okay, so you could maybe try cutting it in half, but these ones have F's and G's, these ones have H's and stuff, so that's not necessarily going to work so well. What I notice is that looking at these, I see two F's here. I see a G here and a G here, and then an H and an H. So I am going to use grouping. I just have to be creative with how I group things together. So I'm going to rewrite this problem, keeping things that seem somewhat similar together. So I'm going to keep my F's first, and then I'm going to do my G's, and then I'm going to go ahead and do my H's. So now based off of this, I'm going to try grouping the blue, the green, and the red together and factor out the GCF out of each of those different parts. So my first two here have a 4F in common. I would be left with 5Y minus 4Z. My green ones here, they have a G in common and a 3. And I would be left with 5Y minus 4Z. My next two have an H in common and a 2. So as I'm dividing this one, I notice I'm getting 4Z minus 5Y. So I'm thinking, well, wait a second, that's similar to what I'm getting here in my other ones, but it has to be identical. So what I'm going to do is I'm going to factor out a negative 2H. And what that's going to do is it's going to flip my signs to a negative 4Z and a positive 5Y left behind. Now, if I were to just rewrite this in a different order, now it is the same as everything else. So all of these here are going to end up being taken out in front. So we're going to do 5y minus 4z. We're factoring that out. And then what's left behind when I factor that out would be 4f, 3g, and negative 2h. Okay, so what I'd like you to do is I'd like you to try number 7. Give it a good try first. Move things around that kind of make sense together, and then come back here to see if it works. Okay, let's take a look at this one so far. So we need to move all of the A's together and all of the B's together. So as we're looking at this, we can go ahead and group those together. Now, if you group them by like the X squareds and the X and the numbers, that also should work. You just have different groups, but you'll end up with the same answer. Once I factor those different groups out, I should get this polynomial here. But before we circle our answer, we have to ask ourselves, does anything else factor further? And the answer for both of these is yes. This first one would be x minus 3 squared. And this next one is now that new formula we just learned. So it's going to be a minus b and a squared plus ab plus b squared. And does anything else factor? Well, no, because we have x minus 3 squared, that's as factored as we can get. And then when we use the difference of cubes, that's as factored as we could get as well. So now we can factor some pretty complex things. Our next step is going to be to take them and to actually solve them. So I'm going to do this section a little bit different. I want you to take 8, 9, and 10, get it equal to 0, and take a moment and first just factor everything. Okay, so go ahead and do that at this time. So here we go. For 8, you had to use the sum and difference of cubes, and you can see your factors there. For 9, you do want to take out your GCF first, and then use your higher powers, and then keep going from there. And number 10, after you group it, you can keep going one more time using your sum and difference of cubes. So after you factor these, you're going to set each part equal to 0 and solve. So what I'm going to do is I'm going to create a separate video just to show you that a little bit more thoroughly explained. Okay?